Students, I am going to discuss about fabrication of machine tool bed using welding in this session. A machine tool bed is normally manufactured using a casting process. This is the example shown here is the lathe bed. The lathe bed is normally manufactured out of casting. Cast iron is the material used for making the machine tool bed. Let it be a lathe bed or any machine tool bed like milling machine table or planing machine table. All the machine tool bed are normally manufactured out of cast iron material. The reason for choosing cast iron as the material for making the machine tool bed is its excellent shock absorbing capacity. Cast iron is having a good shock absorbing capacity. Due to this property, machine tool beds are normally manufactured out of cast iron. But when you want to manufacture a few number of machine tool bed, suppose I want to produce only 5 number of lathe. For producing 5 number of lathe, you have to have 5 number of lathe bed, for which we can able to assemble all the other parts of the lathe. But just for making 5 number of lathe bed, you have to use a pattern. Using the pattern, you have to make the mold. Then in the furnace, the cast iron will be melted and the liquid cast iron metal will be poured into the mold, and upon solidifying the mold, we get the necessary machine tool bed made out of casting. But making a pattern and running the furnace just for making 5 number of lathe bed is not economically feasible. So there is a need to produce the lathe bed using casting only for mass produced components. If the lathe bed is produced in mass quantities, then making a pattern and running the furnace will be the right option. But I want to produce only 5 number of lathe bed. In that case, instead of going for casting, we can manufacture the lathe bed out of other option. Say we can able to fabricate a lathe bed using a welding process. So we can manufacture the lathe bed using the standard components, standard structural component like plate, channels, I-beam, and we can able to join them using welding of required size, T angle, I-beam, C channel, plate of various thicknesses, tube of various sizes and thicknesses. So using these standard structures available in the market, we can able to fabricate a machine tool bed by joining them using welding. So before discussing on how to fabricate a machine tool bed by welding, let us discuss about the welding symbols. If you want to join a horizontal plate with a vertical plate, you can use a fillet weld as shown in this figure. Okay, the fillet weld is the right option to join this vertical plate with a horizontal plate. So let us say the size of the weld what I have chosen is 10 by 10. how to indicate in the drawing. You have to draw the orthographic view of the plates, then this is the welding symbol. Whenever you draw the symbol below the line, that indicates that this is applicable on the arrow side of the welding symbol. So the right side, you have to make a joint. So the fillet weld is to be done on the right side of the vertical plane. So whenever you want to do the welding on the same side of arrow, the symbol should be drawn below the horizontal line. So this is the symbol for fillet weld, a right angle triangle, and this is size of the weld. 10 is the size of the weld. Second example, I want to perform welding on the left side, which is nothing but other side of the arrow. So arrow is shown on the right side, but I want to join the two plate using a fillet weld done on the other side of the arrow. So the symbol should be above the horizontal line, and this symbol for fillet weld, a right angle triangle, and the size of the weld is 12. So the corresponding diagram is here. So the fillet weld is done on the other side of the arrow. So this is the fillet weld. When I want to perform welding for a shorter length, so here in this example, I want to perform welding only for a length of 50 mm. How to indicate this? Now on the arrow side, you want to perform fillet weld of size 10 mm only for a length of 50 mm. On the other side, on the opposite side, then you want to perform a welding of size 8 mm for the entire length. So on the other side of the arrow, the welding is to be performed for the entire length. The size of the welding is 8 mm. The type of welding is fillet weld. On the arrow side, the size of the weld is 10 mm and the length of the weld is 50 mm. Only for a length 50 mm length I want to do the welding. The remaining length is not welded. So this is how you have to show. Suppose if you want to perform intermittent welding, you are not going to do the welding for the entire length of the joint. So the length of the intermittent weld is 50 mm and the pitch between the two successive intermittent weld is 125 mm. How to indicate this on the drawing? So as usual, you have to draw the orthographic view, then you have to draw the arrow and horizontal line. So in this case, we are performing welding on both the sides, arrow side as well as other side of the arrow. So the symbol is present on above the line, below the line. So now the length of the weld is 50 mm and pitch is 125 mm. See here, length of the weld is 50 mm and pitch is 125 on both sides. So you are using a symbol like this. So 12 is the size of the weld, 50 is the length of the intermittent weld, and 125 is the pitch of the intermittent weld. So welding is done on both sides with the same pitch, with the same length, with the same size. Here in this example, there are two circle plates. One is smaller one, other one is bigger one. You want to join these two plates using a fillet weld, as shown in this figure. How to show it in the drawing? Draw the orthographic view of the two circular plates, and so you want to perform a fillet weld of size 10 mm. Since the welding is to be done all around the perimeter of the smaller circular plate, you are using a weld all around symbol. So this is the symbol, a circle which is drawn at the corner of the two lines. This shows welding is to be performed all around the circular plate. So symbol for weld all around is a circle which is to be drawn at the corner. This type of weld is fillet weld. For this example, the size of the weld is 10 mm. When you have a circle, filled circle, that's a symbol for field weld. What is the meaning of field weld? Suppose I want to fabricate a electrical tower. In the industry, I want to fabricate the trowel in 3 pieces. The electrical tower I want to produce in 3 pieces. Then I want to transport this to the place of commissioning, where I can join these 2 pieces together and these 2 pieces together using proper welding method. So this welding is to be done at the site, at the field where I am erecting the tower. So this circle, which is filled circle, indicates this joint is to be done at the field where we are going to erect the electrical tower. So a filled circle is the symbol for field weld. So with this so this example shows a machine tool bed which is fabricated using welding. As I already told you, we can fabricate a machine tool bed out of readily available structural steel which is available in the market. The structural components are available in various shape, L angle, so L angle, C channel, plate, T angle, I beam, etc. So we can make use of any of this standard structure for fabricating the machine tool bed. In this example, I am going to use only plate of various thicknesses for fabricating the machine tool bed. So this machine tool bed is fabricated using welding by making use of plates of various thicknesses. Let us see how it is being fabricated. So the exploded view shows how the various elements are joined together for making the machine tool bed. First, there is a base plate. So the base plate, there is a pocket machined at the center to reduce the weight. So the base plate is the base of the machine tool structure, machine tool bed, over which we are building other elements of the machine tool bed. Over this base, we provide 4 vertical plate. Okay. So those 4 vertical plate. So now this is the base plate. Base plate. Over this we have 4 number of vertical plate. So it has to be joined. So these 4, 1, 2, okay, so 3, 4. So these 4 vertical plate are to be joined with the base using a fillet weld. Then after that, so there is a horizontal plate to be placed over the 4 vertical plate. So before placing the horizontal plate, this horizontal plate is to be strengthened, okay, using a vertical ribs. So we are joining, okay, 2 cross plates and 2 parallel plate over to the bottom of the horizontal plate. So those details are shown in this. So now this is the horizontal plate which is to be placed over the 4 vertical plate. So before placing the horizontal plate over to the vertical plate, it is strengthened at the base, at the bottom side. So these are the 2 cross plate which are welded for strengthening, for reinforcing the horizontal plate. So these are the 2 parallel plate which are joined to the bottom of the horizontal plate for its strength. So this detail shows the vertical plate which are used to strengthen the horizontal plate. So this is the horizontal plate. Over the horizontal plate, we provide 4 smaller plate. We are joining 4 smaller plate, okay, as shown in this figure, for mounting other elements of the machine tool. So these 4 smaller plates are shown here, 1, 2, 3, 4. So these 4 smaller plates are to be joined using fillet weld over to the horizontal plate. So the necessary drawing should include the welding symbols also. So the for purpose of drawing the welding symbol, the lines are drawn with the arrowhead. So now this is the machine tool bed fabricated using welding. So we have drawn the orthographic view of the machine tool bed, okay, sectional elevation and top view. So over this drawing we have added the welding symbol. So for example, we have 4 vertical plate joined to the base using a fillet weld of size 10 mm. So it is to be done on all the 4 sides. Then once all the 4 plates are joined, then okay, there is a horizontal plate. So over the horizontal plate we provide the strengthening rib, okay, using fillet weld of size 10 mm cross, okay, so diagonally placed and as well as parallelly placed. So those things are shown in this diagram. Then once the horizontal plate is placed over the 4 vertical plate, then it has to be joined using a fillet weld of size 10 mm. Welding is to be done on all the 4 sides, so weld all around. Then once the horizontal plate is joined, we place 4 smaller plate, and all the 4 smaller plates are to be joined with the horizontal plate using a fillet weld of size 8 mm. So it should be done on all the 4 sides of each plate, so weld all around. So this is how we have to show how a machine tool bed can be fabricated using welding. So we have to draw the orthographic view of the fabricated machine tool bed, and wherever you want to join using welding, you have to use proper welding symbols. So this figure shows another way or another example for fabricating a machine tool bed out of welding. So here we use 4 number of C channels. So these 2 C channels are placed back to back, these 2 C channels are placed back to back, and all the 4 C channels are joined, okay, using a horizontal tube running through all the 4 C channels. The isometric view is shown here. So we have these 2 C channels placed back to back, these 2 C channels placed back to back, and in order to join all the 4 C channel, we provide a bigger hole running through all the 4 C channels. Through this bigger hole we insert a tube, okay, through the hole, and okay, this tube and the C channels are joined using fillet weld. Okay, similarly this C channel, second C channel is joined with the tube with a fillet weld. So like this, all the 4 C channels are joined with the tube with the proper welding. So the welding symbol are incorporated. So we are using a fillet weld of size 15 mm to join this C channel, okay, with the horizontal tube on both sides. So you have got a symbol on both sides. It indicates the welding is to be done on the arrow side as well as other side. Okay, so like this, all the 4 C channels are joined with the horizontal tube by fillet weld of sufficient size.